Hello YouTube. This is Thursday, March 13th, and I came across a rather niche situation for electronics that I figured I'd share because this is something I was searching for, scratching my head for a while, wondering, hey, what's going on? And eventually found a reference to what was happening. So, many of you like me, will have the venerable 344 ONA, maybe the Hewlett-Packard variant, maybe Agilent, maybe Keysight. It's all the same meter, just depending on what year it was produced. They are the gold standard for the intersection between a truly excellent bench multimeter and one that's been on the secondary market so long that they're available for reasonable prices. You can reliably pick one up these days on eBay for about the $400 range or less. So I have a number of them, and I periodically will process one, detail clean it, do some testing, document the testing process to show the degree of accuracy it's good to, and then put it up for sale. And something I realized is that of all the tests I've done, I didn't test for AC current. It just didn't occur to me. It never really comes up in electronics. Like milliamps of AC current, yeah. So I have my DMMCheck Plus, and it does go to AC mode, and it will provide 1 milliamp of AC. So right now, we're on the 34401A, we're on amps, we're on AC. To get that is just shift AC current. It kind of auto range there, so let's go down a bit, and then you can see it's a little bit off, so we'll go null to zero it out, and now we will connect our current. You see, that's not right. Right now we're getting 80 microamps, and we should be getting 1 milliamp. So this is telling untruths. Is my meter bad? I was wondering that, but then I have like 3 other 34401As in stock right now, so I started hooking them up, and I started replicating my results, and I was getting skewed results for AC current on all of them, and I'm scratching my head like, okay, is my DMMCheck Plus bad? It shouldn't be. It's relatively new. So I have a higher capability meter right here, the 34465A, and we have that on amps AC. Oops. And right there, pretty dead on 1 milliamp. So the DMMCheck Plus is working correctly. So what's going on? And again, I replicated these results across 4 different 34401As. So I did some research, and it took a while to find, but on the EEVBlog forums, we'll move you over a little bit. I encountered other people. Recently bought Agilent 34401 from eBay, 10 milliamp, reads 2 milliamp, 1 milliamp, 23 microamp. So that is entirely normal within specification. AC ranges on the 34401A have less accuracy below 5% FS, not specified below 1%. In this case, 1% of 1 amp is 10 milliamps, so you would have reduced accuracy below 50 milliamps, and no specified accuracy below 10. So it is a measurement limitation of the 34401A, which I probably could have eventually figured out by reading through the specs, like the detailed spec sheets for the 34401A. But thank you, EEVBlog forum members. In this case, B. Dunham7, thank you very much. So yeah, if you are one of the many people out there who have one of these excellent meters, and you also happen to have one of these rather useful DMMCheck Pluses, or some other verification source that provides AC current, but it's low AC current, like this is 1 milliamp, and you're scratching your head wondering, does my meter work for everything except that? Is my cal source bad? There you go. You can't rely on the 34401A below, below the 50 milliamp range, and touching on 50 milliamp is really the rock bottom of current that you can go to and get even somewhat accurate results. It was just not spec'd for it. So I thought I'd share.